So, all YouTube family, welcome to today's videos. So, let's start. So, आज का हमारा टॉपिक है इंटरेस्टिंग फैक्ट्स अबाउट द सोलर सिस्टम. While most of are stuck on planet Earth, we are lucky enough to have a fairly transparent atmosphere. This allows us to look up at the sky and observe changes. The ancient noticed planets wandering across the sky and occasional visitors such as comets. Thousands of years ago, most thought the stars ruled our destiny. Today, however, we can see science at work in the planet, asteroids, and comets close to home. So, why take a look at solar system? We can it teach us. We all know the famous International Astromo- Astronomical Union vote in 2006, where Pluto was demoted of planethood into a newly created class called dwarf planet. But the definition drew controversy among some, who pointed out that no planet dwarf or otherwise perfectly clears the neighborhood in its orbit of asteroids. For example, moons are considered to orbit around planet, but that does not cover situation such as moons orbiting asteroid or double planets. For example, goes to show you the solar system requires more study to figure this out. Comets and asteroids are leftovers. No, we don't mean leftovers to eat. We mean leftovers of what the solar system used to like to look like. So while it is easy to get distracted by the weather and creators and prospect for life on planets and moons, it's important to remember that we must also pay attention to smaller bodies, comets, and asteroids. For example, could have brought organic and water ice to our own planet, providing what we need for life. So, next, the planets are all on the same plane and orbit in the same direction. When considering in IAU's definition of planets, we come up with 8: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You will notice that these bodies tend to follow the same path in the sky called eclipse, and that they orbit the sun in the same direction that supports the leading theory for the solar system's information, which is that the planet and moons and sun formed from a large gas and dust could that condense and spun. We are now near the center of the galaxy. We can measure vast distance across the universe by looking at things such as standard candles, a type of exploding stars that tend to have same luminosity, which makes it easier to predict how far away they are from us. At any rate, looking at our neighborhood, we have been able to figure out we are now here near the Milky Way galaxy centers. We are about 165 quadrillion miles away from the center supermassive black hole, NASA says, which is probably a good thing. This is our Milky Way galaxy. But the solar system is bigger than you think. Beyond the orbit of Neptune, the furthermost planet, it takes a long time to leave the solar system in 2012, some 35 years after leaving Earth on a one way trip to the outer solar system. Voyager 1 passed through the area where the sun's magnetic and gas environment gives way to that of the stars, meaning that it is interstellar space that was a astounding 11 billion miles, 17 billion kilometers away from Earth, or roughly 118 equivalent Earth-Sun distance astronomically units. The Sun is hugely massive. Just how massive 99.86 of the solar system mass is in our local star, which goes to show you where the real heavy weight is. The Sun is made up of hydrogen and helium, which shows you that the gases are far more abundant in our neighborhood and universe generally that the rocks and metals we are more familiar with here on the earth. This is a figure of sun. We haven't finished searching for life here. So we know for sure that life exists on earth, but that does not rule out a whole bunch of other places. Mars and water flowing in on it in the ancient past and has frozen water at its poles, making astrobiologists think it might be a good candidate. There are there also are a range of icy moons that could have oceans with life below the surface, such as Europe at Jupiter and Enceladus at Saturn. There, there's also interesting worlds of Titan, which prebiotic chemistry that was a predecessor to life on its surface. We can use the solar system to better understand exoplanets. Exoplanets are so far away and so small in our telescope that it's difficult to see very much details in the atmospheres by looking at the chemistry of Jupiter. For example, we can make some predictions about gas giants further afield. If we look at Earth and Neptune, we can get a better sense sense of the range of planetary size on which life could exist. Those super Earths and mini Neptunes you sometimes hear mentioned, and even looking at where water freeze in our own solar system can help us better understand the ice line in other locations. Thanks for watching.